Okay, I think we are live. So, hello everyone. Good morning, good afternoon, and good evening to everyone tuning in to today's Cype webinar on thermal load calculation of buildings according to the Radiant Time Series Method, or RTSM. So, hello again. My name is Paul from the International Department, and joining me today is our resident technical expert on all things Cype, Martin, from the Technical Experts Department. Say hi, Martin.
Hi, Bob. Thanks.
So yes, we have a very exciting webinar for you today on thermal calculation of buildings. So before we get started and dive into the nitty-gritty of our webinar for today, I just wanted to do a refresh of those that is just tuning in for the first time to our webinar on what is Cype and what do we actually do here, and what we offer to engineers and architects and people involved in the construction industry. So just a recap, okay? So Cype is a Spanish technical firm specialized in developing and the distribution of technical software for the AEC industry. And the software can be categorized into four main categories: for architecture, MEP, structures, analysis and design, and project management. For the entire life cycle of a building project, you have Cype at your disposal as well. Other than our software that we provide, that we offer to our users, we also offer as well a digital workflow via the BIMserver.center, our Common Data Environment Platform, our CDE platform that houses all things Cype, and as well as a platform where you and other engineers involved, or other people, collaborators and stakeholders involved in a construction project, can collaborate together in a single platform for completely free as well, if I may add. So just to give you a brief background of the BIMserver.center, I'll just go here and type BIMserver.center/en, and you'll come up with this image, okay? As you can see. So what I want to show you right now actually is our store. And this store houses all things Cype from the four categories that I've mentioned earlier. And what I want to direct your attention to for today is the software that will be highlighted by in today's webinar, okay? Let's go to energy analysis and let's go to CYPETHERM LOADS. And this CYPETHERM LOADS, again, is a thermal load calculation of buildings according to the Radiant Time Series method proposed by ASHRAE. So I think with this, I would leave it to my colleague here, Martin, to discuss more about what is actually the Radiant Time Series method and to discuss more about the program for CYPETHERM LOADS, okay? I'll stop sharing my screen for this moment, and I will let my colleague discuss more about the program. Okay, Martin, it's all you. Let's see. So what is exactly CYPETHERM LOADS, thermal loads, and the RTSM? What can you tell us about it?
Okay, well, okay. Thank you, Paul. Today's presentation, as you said, is about the calculation of thermal loads according to the Radiant Time Series method. First of all, I always like to start telling what is the thermal load calculation. It means the amount of energy that you need to add or that you need to remove heat energy in order to reach and maintain certain design conditions inside a space. For example, certain temperature. That's the goal of the calculation of thermal loads. And as most of our audience will know, the most widely used method is the Radiant Time Series method, which is the one proposed and recommended by ASHRAE. First of all, the program itself will explain to us how the calculations are made, or in which codes, databases, which methodology the calculations will be based. This is a screenshot taken from the program itself, and I'll talk briefly about the radiant time series method itself. It is a method for performing thermal load calculations. It derives from another method called the heat balance method. And as I've already said, is the most widely used. It replaces other methods, other popular methods that were used, like it was popular, the CLTD, for example, or the other ones that you may see on the screen. Main characteristic or thing I'd like to explain about it is that it considers the outdoor conditions as periodic conditions. The heat gains and losses through the building elements are considered taking into account periodic outdoor conditions that, of course, will depend on the location, for example. And one of the main values or the most important reasons for using this method is the clarity. It relies in factors, in coefficients, and the fact that it splits the losses and the gains of heat between the different elements is an interesting help for designers, not only for the calculation purposes, but also to know about the performance of the energy in the building. For example, splitting the different gains and losses, separating the ones that.
Sorry, Martin. Yes. So you were just saying very interesting things about like considering the heat gains, the losses, and the building efficiency of the project. And again, talking about sustainability. These concepts seem to be a bit, I would say, more in fashion nowadays. I'd say more and more people are considering these concepts and these concepts in their building projects. But who actually is like who would actually be able to use the tool that we are going to present for today?
Well, as you say, these concepts are relevant nowadays. They have always been. I mean, designers have always taken this into account. But for example, the performance of the energy, or even the economy, the bills, and the cost of the HVAC installation, all these factors are really relevant, and they're more relevant nowadays. It's useful for all sort of professionals of the area. Mainly, this is a necessary step for sizing the HVAC equipment. So first of all, it's useful and necessary for the professionals that are in charge of these sort of installations. But as I said before, there's an interesting use for these tools, that is information that comes and that may be used by designers and by all sort of professionals, project managers, all the professionals involved in this process.
That's very good to know. I think now that you say that, it's a versatile tool that can be used by project managers, can be considered by the HVAC engineers as well, and even in the design stages as well. And I think for the people that are joining us live in our webinar today, in our event today, are coming from different places around the world. So I think they would also be interested in understanding that, yes, this is an internationally recognized tool because it is done in collaboration and with the thought of ASHRAE, as you said. Is that correct, Martin?
Absolutely. That's a relevant information too. The method is proposed and recommended by ASHRAE, which is the American Society of Heating, Refrigerating, and Air Conditioning Engineers. And the program itself that we'll use does all the calculations according to their documentation, to the documents provided and published by ASHRAE.
This as
it is a recognized authority in the area all over the world.
I see. And I think this, I assume as well that they also take into consideration, and our program as well, by effect, different codes in in the calculation of considering the heat gains and heat losses as well. Is that correct?
Correct.
That's
Absolutely.
good. That's good to know, especially for the people that are joining us, maybe that are using these standards in their own countries as well. That's good. Sorry to interrupt. Please continue, Martin. Yes.
Okay, I think I'll just go ahead and show how to use the program, how this workflow would take place. So I'll just go ahead. In this slide, we may see the recommendation of how the data should be introduced into the program in that order. That's simply a recommendation. But I think it will be more interesting if I just show you. So I'll go ahead. First of all, I'll start with the modeler. In this case, I started this process by using IFC Builder, which is a free and professional and powerful tool that's meant to model a building in a 3D mode, and it makes us able to use this model in a BIM workflow because it contains information of each element, so that programs will know that a wall is a wall, a roof is a roof, and so on. So just wanted to show you this screen in which we simply have a 3D BIM modeler. In this case, it's meant to work from a 2D mode, but we have a 3D output. As we see, I'm just modeling a room there, and I won't go too much into these possibilities, but they're just there. In this case, we're using IFC Builder. As we said before, we might use whatever other modeler. In the upper right side of the screen, you'll see my name over there, Martin, and then a name, which is CYPETHERM IFC Workflow Example, which is the name of the project that I have already created in BIMserver.center, the platform you showed us before. And so this project, this model is linked to the platform and to the project created there. So when we click share, the information is uploaded to the platform, and from there we will be able to import it into our tool, CYPETHERM Loads. And I will show an example of how I do that. I'm here in my BIMserver.center page. This is the place where the information is uploaded. As you see here, the residential building.ifc, that was the file I was showing just a minute ago. And from there, we simply open our program CYPETHERM Loads by clicking the icon. I have already prepared the files. I will show two things. One of them will be a file that has already been prepared by me, so that we may show the possibilities of the program. But I also want to show our audience how to import the information right into a file that's newly created from scratch. So just click Open CYPETHERM Loads, and this is the window that we'll see. I'll go ahead and click New. Won't even change the name. We'll just accept. And we have this window. So here's where I will select the project. In this case, this is the one. What I will import is the architectural design, the information of the geometry, and that's it. Just simply click Accept.
Okay, so while this is loading right now, Martin, so importing the file, so now the program, what we're doing right now, what you're doing, correct me if I'm wrong, so we're importing the architectural model from the BIMserver.center to the program, right? Via an IFC, okay. And how long, for example, would this normally take just to get the architectural model and to put it into another program if not using the tool that we're showing here today? How long, like normally, in your experience from before?
This is a really good question. And it is also the reason that I chose to do this import here today, because as we saw, it's maybe a matter of seconds or maybe a few minutes, depending on the complexity of the model itself. But after that, we have the geometry available for us to start calculating and processing this information. If I had to model the whole building again just for doing the thermal load calculations or any other steps, any other step of the building project, if I had to model the whole thing to calculate the structures or to generate the bills of quantities, to study the costs of the project and so on, the modeling might take days, maybe a week. And from my personal experience, maybe a model of this complexity would take that long. And we've changed that for a few minutes.
It seems hard to believe, but that is the case, right? We've seen it. You were showing it live today, and it's quite a powerful tool in that sense, like in a way of minimizing, not even minimizing, like from a week to like how many minutes for you to explain your answer to the question I asked. Yes,
it's amazing, even if it was from hours to a few minutes. It depends on the complexity of the building, if it was a single home. But anyway, it's just a few clicks. And what we see here is the model in the program, thermal load, Cype thermal loads, and a lot of error messages, error alerts. They're not nice to see, but I wanted to display this here today because it's actually good news. This means the program is the program is helping us. As we see these error messages that says this is not defined, this is not defined, and also we have like orange checks here, like square little orange messages that they let us know that we haven't worked there yet, and we have to. So we won't skip any of the important things we need to do. On the other hand, once we've worked on the project, this would be the look of the same file. I have the both views available here. So before starting to defining the elements and assigning those elements to our actual spaces contained in the building, I'll show you this thing I'm talking about the errors. For example, we have here a few types of spaces. In this case, we have, for example, a garage, and we have an error message there. So we'll just go ahead, edit that. For example, we may define that in this case, we won't do anything with this space. We won't heat it. We won't cool it. It will be not part of our HVAC today, so we may decide it's not occupied. Just go ahead and define those parameters and click accept. And as we see, the error message is no longer there. That was what I wanted to show. The same with any other space there, and that is exactly the same with the elements such as the walls, the roofs, doors, windows. Once we've defined the building solutions we will use in this project and will be taken into account for these calculations, once we define those elements, the errors start disappearing. And on the other hand, once we've defined the elements, we will go to our project. And in this tree on the left side, we have on one hand the libraries, and on the other hand project. Libraries are the different sorts of elements that we have in the project. And the project part of this tree is the actual spaces, the actual elements and spaces that are in the project. So we will assign different types of elements to the different actual spaces we have. For example, we see in this garage, we have many different elements such as slab and ground floor, partition walls, facades, roofs. So when we start assigning these, first of all, we'll show the space. If this wasn't a garage, if it was a lift, we will just have to choose lift. And all the information we've defined in the libraries area will be displayed here. So that's the process. Once we defined the libraries, we start assigning to the project the proper library we've already defined. In this case, it is a garage, so I'll just click garage and it is assigned. So we'll go ahead to show a little bit more of this in the correct file. So first of all, I always like to start showing the 3D viewer, because it's an important tool that helps us know where we are moving and what are we doing and where it is taking place within the project. So for example, when we select kitchens, we see the spaces that are defined as kitchens in the project. When we select bedrooms, for example, we may see where they are in the 3D viewer. And on the other hand, this is talking about the libraries area. So for example, if we click the elements that are walls, we'll see in the 3D viewer the walls that are in the project. And this is the same for the spaces. For example, on the zones, we may go to the bedroom 1A and we may see where it is. That is the first thing I'd like to show, because this is an interesting and relevant part of the program.
Okay, so now that you've gone and defined the elements from the previous model that you were showing, now in this what we're seeing right now is the project where the elements have been defined. And what else what do you need to consider, and other parameters, other design conditions that could be considered for the program to make the output later on? What are the conditions? Because now we're seeing, yes, now the elements have been defined. What else can we input to make it more effective, robust, like the details and the reports that we're going to get later?
Yes, I think that the interesting thing to know would be, how do we define, how do we get there? And I'll show you how we define the design conditions, for example, for the different spaces, which will be the temperature, which will be the amount of people there, what will cause the heat gains or losses, that I will tell the program that it needs to consider them. So I'll show you how to do that. For example, we have the spaces. As we see, we have different sorts, types, kinds of spaces. And let's show us, for example, the kitchens. In order to add a new kind of space that I'd like to define, we just need to click Add and just choose a name for it. If we want to edit one that is already there, we'll just click on the element and choose Edit. In this case, it is a space that we will heat and cool. And this is the place where we choose that, if we want to heat it, only cool it, or both, and to choose if it is a space in which we'll do actually something or not. Here we may manually choose the design indoor temperatures, both for cooling and heating. You can change these. We can choose whatever. the program already recommends temperatures, but we may edit everything. For example, causes or ways in which heat may be gained or lost in a space. Ventilation is one of them. So we may define here these parameters. For example, what will be the ventilation? Professionals in this area know all this, but okay, we may know the principles and why we need to consider ventilation here, but maybe we won't actually remember what should be the numbers for each single kind of space that may happen to be in the projects. So the program helps us. We have powerful databases, as we said before, and just by clicking this blue arrow, we have information coming from ASHRAE in which we may decide, okay, this is a kitchen. And ASHRAE says, suggests that the correct flow per person, flow of air, will be that one. So we'll just click accept, and the program shows it that information. I think this is a real powerful tool. And also, for example, today we're talking about a kitchen, but we might be talking about, for example, an office or a school. Whatever space we're talking about might have different profiles of use, different schedules, different hours. An office won't be crowded maybe at night. A school will be empty in August, for example. This is information that is relevant to take into account to be more precise. So in this case, the program allows us to define, for example, this information as precisely as we need. We may choose a constant percentage, for example, saying, okay, a kitchen won't be full the whole day. Maybe it will be in use at 30% of the day. And we just may define that, as we see, manually. We'll be choosing the different numbers of our choice. Or we may go further and choose a daily profile, which gives us access to an actual schedule. So if we're talking about a kitchen, maybe we'll decide, okay, it will be in use in the hours that we'll have breakfast, for example, maybe just randomly choosing numbers here, but 6 a.m., 7 a.m., 8 a.m. If it's a family, maybe they have different hours. And maybe it will be in use before the hours that we'll actually have our meals. So 12 o'clock may be crowded, and that's it. So we may define those little things here. And the same happens. We may be as precise as we need. And just by clicking accept,
that level of customization is quite interesting to really get into, especially for our viewers, right? I mean, for example, here in Spain, we might have different times, and maybe for eating, as what you were saying, for using the space that what is the purpose of that space, and maybe some in a person or a viewer from a different country, maybe in Southeast Asia, in America, the US, or Latin America, would define the spaces quite differently. And that level of customization is quite good. And it really depends on what the user needs for the program to be, what they need out of the program. So this level of customization, are there more customizable aspects to the program? Let's say, for example, that you were showing here, maybe in Celsius and in meters. And are there any other metric systems that we can get and see in the program that could be considered as well?
Yes, there are. There are more options, and those aspects that you're mentioning, we may customize those too. I'd like to say that all this information we're defining here We may always save it. For example, in this case, I would choose a name like kitchen maybe. And by clicking this red arrow here, we'll save it. And we may reuse this whenever we need. So we'll just click accept. We set our parameters as we need, as constant percentages, daily profiles as I showed, or maybe leaving everything just 100% and that's it. And we may reuse that information maybe in another space or maybe in another area. Instead of ventilation, we may consider that we will also recycle that information for the lighting parameters. So if we choose to use a schedule here, we may go ahead and look for the ones that we've already defined. A minute ago, I defined kitchen, so we may use it, and that's it, and it's imported. I have different options, and I don't have to be constantly doing that work again.
Yes, it saves you time. It saves you the effort of like redoing everything. You just copy and then paste it into the next parameter that you need.
And we will have help for the different areas we need to have access to precise information. In this case, for example, for lighting, we will also go to a database coming from ASHRAE, and we may choose, okay, this is a dining area for a family and the sort of lighting that takes place. So the program suggests good values or values that are suitable for our calculations. And we, as we said before, always may edit those. So we have complete control of all this data. Let's go ahead with accept. And you asked before about the units. This program may be used all over the world. So when we go to the upper right side of the screen, we have an area that's configuration. We click on that small world there, and we'll see a command, an option that's units. By clicking there, we may choose whatever unit we need to work in. So for example, instead of meters, we may choose feet. Or for example, if you're working here with thermal measure units, instead of watts, I may want to work with kilowatts or with other units. So we may customize that. And by just modifying the information and clicking accept, the program automatically will update the whole information. As you see, I haven't made any changes here, but if I had made them, they would be automatically calculated and displayed in the different the whole project. So once we change the units, they're completely changed in an instant in the project. So I'll just go ahead. For example, that was talking about different kinds of spaces. For example, as we see in the lift, we decided it's unoccupied. That means that we won't heat or cool that area. The garage, as we said, it would be the same. In the case of the corridors, we might decide, okay, this would be occupied maybe at 20% of the time. And all the different information that we may want to take into account about the internal heat gains produced by the occupancy. Again, we have suggestions coming from recognized databases. So we may decide, okay, this corridor will have 2 people, probably not 5, or we may decide, okay, what's the suggestions here for hotels, motels. We have different lobby of a hotel, for example. We may decide, okay, that's a suitable number. And we may also decide, okay, this space won't be in use the whole time. There won't be 2 people or 3 people 24/7 there. There will be 2 people, maybe 2 hours a day because they come and go. So this is the use of all these tools. Another relevant area in which we may define elements of our building, of possible elements for our buildings, is the actual place called elements in the tree. Here we have walls, roofs, and as it is obvious, different kinds of walls, a thicker wall or a wall with more layers will lose less heat, for example. So the thickness, the amount of layers, the building solution that we choose will significantly affect the calculations and the project. So for example, in this case, we may always add a new solution just by choosing a name here and clicking accept. We have a new one to edit. We have, for example, all this has been defined, but I'll show you how. We have, for example, a wall, which is the element that will be assigned later on to the whole surface of the outside of the building. So we click edit. In this case, we are talking about this element. We may choose over there if it's a roof or a wall or a party wall. And we may define the whole element by a simplified input by just writing the numbers that we consider. If we already have the information, but we don't want to go into carefully defining the layers, we may just write the numbers that we need, and that's it. But there's also relevant aid here by defining by layers and clicking add a layer. First of all, we have the possibility to add, if we're talking about a wall, maybe we'll need to define the structure of the wall, maybe a brick. And how do we do that? We choose the aspect for the graphs, for the drawing. And we may also rely on the help that is always given by the program. And again, we go into relevant information coming from a relevant database, coming from ASHRAE's handbook. And okay, we're talking about a brick, just we choose it. Or if it was a concrete block, okay. And we don't have to remember or to go into 3 books to carefully look into a table or have 30 files open with different databases to be actually checking, okay, do I have the right numbers here? The program allows us to access that information easily and in a tidy way. So
that's good to know, like the level of customization that you could do for the program. It is at this point, like it's very detailed. You can customize it to however you want. And you were talking about like the spreadsheets earlier. Now that we have defined and customized everything that we need to do for the project, for it to do its job properly, what can I expect now? The program, what can it do? Can it get anything? Can it analyze everything? What's the next step in this?
That's a good question. What we will get out of the program, right? I'll tell you right away. Before finishing with this part, I'll say that we may define by layers. We may simply introduce numbers, but we may also access to the different complete building solutions. So with the whole thing, with the different layers available there to see. So we may just access the databases, and this is really productive because we have the information in an order, tidy, and step-by-step way to get to it. This is for defining elements. The same would be if this is a wall. The same would be it would happen with the roofs. In this case, these are predefined solutions that we have accessed by using these helps that I just showed. So what can we get? Once we define the elements, spaces, elements, doors, windows, a powerful tool that we have here is the edges processing. As we know, a space will have many edges. Any volume, any 3D prism will have many edges. So imagine the amount of edges that a building may have, and we need to take that into account, because if it's an edge that contacts an exterior space, it won't be the same that an edge that contacts an interior one, because the heat losses will be significantly different. So once we've defined the elements of the libraries of the building, we'll go into linear thermal bridges, just hit edges processing, and the program will do all the job by itself. We'll just click configuration here to know what the program will do. And according to the code that we choose, in this case, I'm choosing one that's in English, the program explains what we'll do with the edges. In this case, it is the worst case scenario, the worst case for the thermal transmittance, in accordance to this code, which is that number. And as always, if we're not fine with that, if we have another number, because we have the information, we may always edit it. Instead of 0.5, we may choose as a good solution that we know that we're implementing in our project, and maybe hit 0.3. If we know what we're talking about and we know that our numbers are different, we may just change them. If we don't, we just choose the worst case scenario, click accept, and that's it. By clicking accept, the program will do all these calculations, okay, all these numbers here, all the definition of these edges had been done that way. I haven't been defining all these one by one, because there are many of them, as you see. If we saw the other file, this would be the look, the aspect of that area. Once we define all the elements, we'll just click edges processing, and that is really productive. And once we define the whole libraries area, we'll just go into the project area and check that, for example, the garage displayed here in the 3D view is actually defined as garage. If I was mistaken, I would choose, okay, this is not a garage, this is a corridor, that's it. And it will import the conditions of the space that had been defined before. So we'll just go ahead. What may we get from this program? First of all, those are relevant, useful tools to go and define the model. And what we have here is the analysis tab. We've changed it from the thermal model tab to the analysis tab. Here's the page, the screenshot I showed before, where the program explains, okay, this is the way that I'll analyze the project. And we may choose and define different zone hypotheses. For example, in this case, it is a residential building, it's housing. So the zones that we defined are 1 per unit. For example, if it was another sort of building, we might decide, okay, the units will be not the houses, but maybe the floors. So in that case, if I wanted to add a new or different hypothesis, I'll just go ahead and hit hypothesis maybe 2. And if I wanted to decide, okay, I want the calculations not by units, but maybe by floors, I'll just go and select the spaces that are in the floor 1. For example, I choose corridor under 1, the house that's called 1A and 1B, and now I'll just choose a name. And as we see, we're choosing the whole floor. That's just an example of what we may do here. And before updating results, that's the button that will actually do the whole calculations. What we'll do is to define the options for the program to calculate. As we said before, the radiant time series method takes into account the outer conditions in a periodic hypothesis. So what we need to choose here is the location. In this case, it's Alicante, the one that we've chosen, but we don't have to know all these numbers. You may know them, but you won't know the whole set of numbers for every single city in the world. you will have to access a correct database. In this case, we have those databases here. The way we defined Alicante here is by me choosing Alicante within the options of the program. We just choose, okay, Alicante here, click accept, choose this city, click accept. This is the database that the program has contained in itself. And we also have the one provided by ASHRAE. So we may choose here, okay, I want the information for Alicante according to ASHRAE. In this case, I chose this one. So I just click it, accepts, and that's it. And that are numbers. And if I have more accurate information, if I know that maybe in my case, the numbers are different, again, I may edit them manually. So this is really relevant for the calculation of the thermal loads. The outdoor conditions, as we see, we have access to all this information by just through just a few clicks. And we also have the possibility to decide the analysis method that we want to take place. In this case, I want alter the default settings, just leave them as they are, but you have control over those aspects too. Once we've done all that, we just hit update results. Again, we'll see it will take seconds, maybe a minute. It depends on the size and the complexity of the building. Now we'll just go into one of the zones and we have access to the calculations performed. In this case, we have graphs. We have, for example, the peak cooling load, the peak heating load, the progression annually. And here we are talking about this zone, be one of the houses.
Okay, this is quite interesting to see, and it really saves the time, and you can just see it visually here in the program, the graphs as we were talking about, and just to see what the program can do, and depending on what you need it for, make a decision already based on what the program has generated. Now, for the interest of time, I think, Martin, is it okay that you can show us a bit now that we've gotten this? What can it do now? Can it import more to another program? The file that we have here, and can you show us a bit about that?
Yes, really interesting to know it is that not only we have the graphs here, but also we have access to the complete report. In this case, it is the complete report for the zone. People take a lot of time to do this whole set of documents, and we have it here automatically generated and with precise information coming from the calculations. As you said, if you're watching this information and say, okay, these numbers, I'd like to improve them, well, we have the information of how we got to those numbers. Maybe I need thicker walls, maybe I need less windows, maybe I need more. So those decisions, as you said, are really important for a design process. And here I'm showing the complete report set for one of the zones, but if we click the list of thermal loads button, we have the complete report for the whole project in a document that you may just print, save, send to whoever you want. In this case, it will be a PDF. And that's it. And not only we'll have the information that comes from the calculations of the thermal loads, but also we'll have complementary reports in which we'll be able to get, for example, an interesting and or tidy and really automatically generated and correct information of the building solutions, the building elements that we've been defining through all the earlier phase of this project. So we have all the information here to print it, save it, send it to whoever we want. You were asking, okay, we have this output. May I use all these from another program to actually maybe size an HVAC installation? Yes. Once we've done all this, we'll just need to hit share here, a name, and click accept. And It would take a few minutes again, maybe 1 minute, maybe less, maybe 2 minutes, or maybe more. But you've seen the process. In this case, I'll just show you what would be the look of that upload here in the BIMserver.center screen. That's the contribution called thermal loads coming from CYPETHERM loads. And it won't take much longer for me to show how would this information look from another program. I chose this one, Cype HVAC Radiant Flow, because it is really visual. We have simply linked this file with the project in which we're working. Here we see all the settings from the BIMserver.center area. And as we see, this is what we have imported here, the information of the architectural design and the information coming from thermal loads. I just did that. It has already been prepared for me. I clicked accept. Again, 1 minute, maybe 2. And we have this in the program. In this case, Cype HVAC Radiant Floor. And I chose this one, as I said, because simply by moving the mouse around the project, I'll see the numbers. As you may see in the center of the screen, we have, okay, heating load, those numbers in watts. Sensible cooling load, those other numbers in watts. I haven't defined this from this program. This information comes directly and automatically from CYPETHERM loads. And it is here for use to define the heating or the installation of the radiant floor.
And yeah, this is very incredibly useful. Like you see how it really saves you time. You don't have to manually input everything all over again from the very beginning. You just have to import and to the program that we have here that you're showing. And this is also true. I would like to remind our viewers as well that this is also true for other Cype HVAC software that we have out there, not just for radiant floors, but also for the ductwork as well. Is that correct, right?
Yes, this is correct for ductwork, for any other HVAC installation that we may work in from our programs. And as you see, it's the same for the architectural model for the building. We not only have imported the thermal loads work, but also we haven't been modeling the whole project again to maybe project to design a radiant floor installation. We are just recycling the information, we reuse it to be more productive. And maybe to finish, I wanted to show in this 3D view area from the same program that we not only have imported the numbers, but we have also imported the information of the building solutions that we have decided and designed for the calculations. So in this case, we may see that we have maybe 12 centimeters of an isolation here with this thermal resistance. Again, I haven't been defining layers here, maybe stucco 2 centimeters with these properties. No, this information is red, as we see here in the elements red area, from what we have already decided in the other program. In this case, it is by layers. We may choose, okay, I don't care about the layers. I want to know the whole solution, this thickness, that thermal resistance. And I think this is really useful, not only the numbers for the watts, but also the whole system, the whole set of systems and solutions that we defined are also imported and exported.
Okay, that's incredible presentation. Like you see how powerful the tool is, not only in helping you define the necessary conditions as well as the heat gains and the losses for the program to analyze, but it already gives you the output in various ways, from like the documents, the reports that we saw, and the drawings, and even the graphs. So you just need to look at it, analyze it in a bit, and then decide for yourself a big decision based on that for your project. So
okay,
now,
sorry, do we have
yes.
1 more second?
Yeah, I think we need to. Yeah, okay.
You said the word drawings, so we have the access to automatically generate drawings from here. I didn't told that, but we have a platform in which we not only have the reports available, but also we have the whole set of layers that we may actually print from this program, and this would be the look of it. It's a schematic information defining and showing visually, okay, the solutions for the internal partitions. That's another tag. That's it. From sorry, Paul.
Yeah, sorry. Yeah, of course. And that's good to know as well for like the people that would be interested in getting the drawings as well from the program itself. Not only can you do the reports, but you can also do the drawings, of course. And now I think I just want to ask, now that you have finished a great presentation, by the way, Martin, about the program.
Oh, thank you.
Now that like my final question, I think this is also something that more and more people should also think about. Why is it important that we consider defining the loads in a building project? In this case, the heat loads as well, and the thermal loads.
Okay, this is a necessary step. It's not that it's important. It is necessary, but it is a good question because maybe there's the risk of oversimplifying. The alternative to the use of a specialized professional program is to actually manually perform these calculations, and this means spreadsheets, maybe books, tables, databases, and that amount of work and its complexity leads maybe to maybe quickly skip steps, maybe recycle information from another project, and maybe going to simplification processes that will make us lose accuracy. And there's no need to do so. Nowadays, we have a tool like this one in which we simplify, but we do it the right way. We reduce work in the areas that it needs to be reduced. I don't need to have 3 books in order to be looking for the climate information for this city or that one. I have a button there and I access the correct database. I don't have to remember the thermal transmittance for this sort of wall or that one. I'll just go and check the right numbers and I have them there. So the alternative is spreadsheets, books, actually a lot of work. And we change from days of work into hours of work, and maybe from weeks of work to a few days. That's the difference.
Okay, very well said, Martin. Thank you so much for that. And yes, and you can see and try it for yourself actually on the programs that Martin has showed for today. If I'll just share my screen, if it's okay, Martin, okay?
Absolutely.
So at the moment, I will have it here. I will share it as well in the comment section. A list of the programs that we have seen from today, CYPETHERM LOADS, including the modeling tools that you used. And this is the best part, I think, for the people that are interested in looking at it and trying it for yourself, that it is completely for free. CYPETHERM LOADS, Cype Architecture, and IFC Builder. If you want to import into other to our HVAC programs, you will also need to try maybe an evaluation version where you have 10 days non-consecutive to try out the software for yourself. I'll leave it here as well, the instructions. You just need to make an account, register, download the program, and you'll have 10 days non-consecutive to use the programs that we have seen from today. And with that said, I think if you have any more questions, please, we'd love to hear from you. Please reach out to us. This is my email. And of course, from technical support as well. If you are interested in finding out more about the program or interested in scheduling one-by-one with me or with the technical experts from our department as well. So yes, thank you again to everyone that has joined us today. And thank you as well, Martin, for your first webinar. Congratulations. It was very, yes, we are very, very happy that you have shared your time with us and your expertise regarding thermal load calculation of buildings according to the Radiant Time Series method. Okay, once again, my name is Paul from Cype, and we wish you a pleasant day ahead. Thank you and goodbye.
Thank you, goodbye.